In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your patience time. Today I'm going to discuss my lecture number 1 on light FCC gasoline extraction and sweetening unit. FCC volatile catalyst cracking. Okay, before my lecture I used to read a Quranic verse. قال ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي اللهم ربي زدني علما. O my Lord, open my chest and is a task for me, and loose a knot from my tongue that they may understand my saying. Allahumma rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay, light FCC gasoline extraction and sweetening unit. Okay, today I'm going to discuss a fundamental of operational principles of light naphtha sweetening unit. This is my model number 1. And next we are going to discuss operating window and process interlocks, startup, shutdown and emergency procedures, troubleshooting, advanced process control strategies, corrosion involvement aspects, safety recommendations, and last a treatment unit performance monitoring system. Okay, key takeaway points. My lecture number 1 on light FCC sweetening unit. We are going to discuss today chemical reactions, sweetening, extractions, operating a variable, that is catalyst concentrations, oxygen injections, alkalinity, contact heat and feed. Okay, sustainable development on clean energy. Hydrocarbon treatment journey. What is the treatment process? Light gasoline treatment process is synthesized to extract and convert mercaptan into disulfides, which remain inside the product. Following are the key processes to treat sour gasoline product. First is extraction process, reaction process, and caustic regeneration. In extraction process, only primary mercaptan extracted completely, secondary and tertiary mercaptan partially. In reaction, the remaining secondary and tertiary mercaptan in the gasoline will move into reaction stage. It will react with oxygen in presence of catalyst, so it will react and convert the mercaptan into disulfides. The caustic soda, which contain primary mercaptan, which is extracted from the extraction phase, that has a small quantity of the other mercaptans, react with the oxygen and convert the primary mercaptan into disulfide. Then this disulfide is removed by using naphtha washing and disulfide separators. So sometimes pre-treatment is required based on feed characteristics. If hydrogen sulfide is present a low ppm inside the light hydrocarbon, this must be passed through the caustic gauge scrubbers, ensure complete removal of hydrogen sulfide from the feed. This does not poison the catalyst, but it competes with the mercaptan presence of available oxygens. So on my next slide, I'm going to discuss mercaptan structure formula. Okay, sustainable development of clean energy, hydrocarbon treatment journey, types of mercaptan and structure formula. If we can see here, the primary mercaptans, it contain a single mercaptan, that is R molecule, into secondary mercaptans with a 2 mercaptan R molecules over here. So in tertiary mercaptans, it contain a 3 R molecules over here. If you can see, this is tertiary mercaptans. So in primary mercaptan, it contain only 1 R, 1 H, 2 H and 1 SH group. In primary 2R, one hydrogen group and one sulfide group. In tertiary, 3R group and one sulfide groups. So these are three types of mercaptan which are the part of the feed when it processed in the first stage of treatment process, that is extractions. So the primary mercaptans removed. In fact, the mercaptan extracted from the low boiling point hydrocarbon, that is C3C4 and light gasoline, which contain a low molecular weight of the mercaptan, which is desired and easy to remove. The molecular weight of the mercaptan cannot be controlled. This is a function of crude source and distillation cut of feed. So that cannot be managed by a human. So after extractions or the treatment process, the mercaptan converted into disulfide which remain in the product. To maintain this process, the main role played by the sodium hydroxides. Okay, the sodium hydroxide, diluted sodium hydroxides, caustic soda, must maintain 2 to 5 weight ppm is held minimum injection to provide a needed alkalinity. Based on that, the mercaptan oxidized to disulfides and do not enter into the peroxides reactions in case of insufficient alkalinity. So that is how the system is performing. In the last over here, if hydrogen sulfide is present in the low ppm inside the light hydrocarbon, this must be passed through the caustic gauze, ensure complete removal of hydrogen from the feed. That is a key element must be carried out as far as the feed quality is concerned. Okay, sustainable development on clean energy, hydrocarbon treatment journey. What is the extraction process? Extraction process applied for gas and liquid steam to extract and remove mercaptan content from both steams. The completeness of extraction depends upon solubility of mercaptan alkaline solution. Primarily, this depends on the following. Number 1, molecular weight. If molecular weight is higher or increased, the solubility will decrease. Secondly, degree of branches of mercaptan. If chain of mercaptan branches increase, the solubility will reduce. Number 3, sodium hydroxide concentrations. If sodium hydroxide, caustic soda concentration decline, the solubility will also reduce. Number 3, temperature of the system. If the feed temperature to the system is higher, it will impact the catalyst activities. Okay. Now, that is, we have discussed 4 key elements which impact the solubility of extraction process of mercaptan from the hydrocarbon. Now we are going to discuss the first equations is RSH, alkali group and sulfone group, that is mercaptan in oil phase. When it will react with sodium hydroxides, aqueous phase, it will react and extract a sodium. OH will react with hydrogen and it will turn into the waters and sodium mercaptans, that is in aqueous phase. So the sodium mercaptans will further oxidize with oxygen and water, in presence of water, and it will turn into sodium hydroxide and disulfides. So these disulfides are removed by using naphtha, washing and disulfide separators. So then sodium hydroxide will be able to reuse or recycle into the system as far as the regeneration cycle is concerned. So the caustic soda is regenerated by oxidizing primary mercaptans into disulfides. Okay, sustainable development of clean energy, hydrocarbon treatment journey. What is the sweetening process? Chemical reactions. First we're going to discuss. Sweetening unit reaction will take place only in alkali environment, presence of sodium hydroxides. So if we can see here in my equations here, RSH, R is my hydrocarbon chain state branched or cyclic, but SH organic compound with sulfohydryl function. When it will react or oxidize with oxygen, so it will convert into disulfides and water, and disulfides remain into the product. Second, we mentioned, in fact, there could be mixture of mercaptan to the extent of R chain might have 1, 2, 3, 4, 5, 10 or more carbon atoms in the chain. When reaction occurred, two different mercaptans might enter into the reaction. That could be R and R dash. So R dash and RSH, there's two different types of mercaptans. So these mercaptans reactions occur spontaneous but at very low rate whenever any sour mercaptan bearing a distal is exposed in atmosphere presence of oxygen. It will oxidize and convert into disulfides, so and waters. That is how this reaction is taking place. Now on my next slide, so we are going to discuss 5 other elements of key elements of chemical reaction. Okay, sustainable development on clean energy, hydrocarbon treatment journey. First key parameter for the treatment process is a catalyst. This is vendor or trademark. Secondly, this is not a variable element. After passage of time, the catalyst activity will decline gradually. To recover, this is mandatory the fresh catalyst to be added. Technically, the charcoal is pregnated with 1.4 kg of UOP chemicals. So secondly, the catalyst activity ability of the direct reaction yield of the particle product. The catalyst activity, the active catalyst, its ability to increase the rate of particle reactions. That again, it's depend how the catalyst composition is being managed or being arranged, as stated over here. Okay, sustainable development, clean energy, hydrocarbon treatment journey. Now we are going to discuss a second parameter of treatment process, that is oxygen. Oxygen is mandatory to oxidize mercaptan at standard temperature pressure. Okay, 1 meter cube of air at atmosphere pressures contain 0.28 kilogram oxygen. To oxidize 1 kilogram of mercaptan, a total of 0.8 meter cube air is required at STP. Okay, now over here we will calculate how much oxygen is required. Excess amount of air 1.2 to 2 times theoretical required to oxidize mercaptan completely. Okay, now we will use this formula to calculate how much air is to be injected for oxidizations. Okay, 1.5 K is a constant 8.8, feed rate meter cube per hours and specific gravity at 15 degrees C, and the amount of mercaptans inside the hydrocarbons. So after calculation, we will be able to identify the amount of air required to oxidize mercaptan completely. Now, on my next slide, we are going to discuss alkali. Okay, now we are going to discuss parameter number 3, alkalinity. This is needed to selectively drive the mercaptan oxidation reactions, which is provided by the sodium hydroxide or caustic soda. The caustic soda concentration must be maintained to 10 weight a ppm to maintain a drain effluent 9 to 12 pH. The sufficient caustic soda must be injected to convert into disulfides. Thiophenol, when present with olefins, it can be oxidized to thioethers hydroxide gum crossers. Sufficient caustic soda must be injected to convert diphenol into disulfides. Therefore, The sufficient quantity of caustic injection should be maintained to yield peroxide number of 0.3 or less. Any acid present in the feed lead to caustic neutralizations. As caustic is neutralized, it must be replaced in order to maintain acceptable operation. Now on my next slide, we are going to discuss a parameter number 4, contact retention times. Okay, now we are going to discuss a parameter number 4, contact, residence time, retention time. This is intimacy of mixing reactant. This can be accomplished by one or several means. Characterized in durations of time mixing by volumetric ratio or by differential pressure, which implies degree of dispersions. With fixed flow restrictions, the differential pressure is directly related to the linear velocity. This could be a process variable. Number second, the pore structure of charcoal provides the worst interfacial surface area for contact between hydrocarbon, caustic, and catalyst. Characterized contact is residence time in the charcoal bed. This is expressed volume of feed per hour of catalyst bed for common term liquid obviously space velocity LHSV as residence time. Increases, the LHSV will decrease. Mercaptan convergence increases. As the catalyst bed accumulates running time, the charcoal pores tends to plug and become blinded by extremely heavy hydrocarbon molecules. This reduces contact and is largely the cause of fixed bed deactivation. Fixed bed deactivation results in higher mercaptan content in the product, which will not respond to corrective action. Either reduces feed rates for lower LSHV or catalyst bed reactivation will be required. Now in my next slide, we are going to discuss a parameter number 5, that is heat and temperature. Okay, now we are going to discuss a parameter number 5, heat or temperature. Sweetening unit supported by the high temperature. If heat temperature is higher, the mercaptan conversion will increases. But high temperature will also give adverse impact on other processes. Gum crushes formations and premature catalyst bed deactivations and metallurgical concentrations. Therefore, the feed temperature must be kept as low as possible within 40 to 48 degrees Celsius. Increased temperature will also enhance other oxidation reaction which may be undesirable because of color deteriorations, gum precursors formations and premature catalyst bed deactivations. This is my last parameter of our key parameters of a treatment unit. So from my next slide, we are going to discuss the equipment of participating into a treatment process of light hydrocarbon. Okay, feed quality. Successful mining units operation requires the removal of or neutralizations of any compounds or impurities that could cause a catalyst deactivation, interferences or degradations of a treating a chemical and solvents. First is elemental sulfur, second hydrogen sulfide, and third carbon dioxide. First, elemental sulfur. Elemental sulfur, once formed, is very difficult to remove. None of the equipment in the Merox unit is capable of removing elemental sulfur. Every precaution should be taken to prevent its formation in the first place. If it is found to be present in the feedstock, its origin should be quickly identified and corrective action must be taken. Number 2, hydrogen sulfide. Low concentration of H2S hydrogen sulfide may be removed by caustic pre-washing, that is by washing the hydrocarbons stream with a dilute solution of caustic soda. Dilute caustic solutions are necessary to prevent the Precipitation of sodium sulfide, that is Na2S crystals. Economic consideration are usually limit the practical range of H2S hydrogen sulfide removal by this method to hydrocarbon stream containing not more than 100 weight ppm hydrogen sulfide. Hydrogen sulfide cannot be normally tolerated in Merox feedstock in concentration exceeding more than 5 ppm. Okay, next is carbon dioxide. Carbon dioxide is commonly in light hydrocarbon fractions, mainly as a result of contamination which occurs in catalytic cracking. However, it is an acidic contaminant and thus may be simultaneously removed with hydrogen sulfide caustic, washing or amine extractions, absorptions. Since it is an acid, it must not be overlooked when setting a pre-treatment equipment operating a parameter. A small amount of CO2, carbon dioxide, is also naturally present in atmosphere air, about a 300 volume ppm used in the Merox process as well. Okay, now we are going to conclude our lecture. Today what we have discussed: chemical reaction, sweetening, extraction process and its operating parameters, that is catalyst concentrations, oxygen, injection, alkalinity, contact, heat, and certainly feed quality. Okay. My next topic will be a process flow description, which are going to discuss extractions, reaction section, caustic regeneration, and we're going to demonstrate a simulated model. Okay, references: Qatar Petroleum Doha Qatar, which I have worked 24 years. Oil and Gas Development Corporation, we have worked 2 years. World Energy's Outlook 2013, US Geological Survey, US Department of Energy, Schellenberger's feed, International Energy Agency's Wikipedia, Oklahoma, State Oil Facts, Norsex, The Story of Oil in Pennsylvania, Air Liquid Gas Encyclopedia, Natural Gas from Weller to Burnaby. Okay, please do not hesitate to send me your feedback and comments t.masood.dr@bath.edu. You may send me your input through my WhatsApp number. I have also provided my WhatsApp number. Together, everyone achieve more. Thank you very much for your precious time.